Hello, Assalamualaikum. My name is Muhammad Irfan Danish Bemo Jafri from UiTM Pasir Gudang, Cawangan, Johor, taking Civil Engineering course, class EC110482. Today, I would like to present for my mini project assignment, ECG 263 Soil Engineering Laboratory, about soil stabilization with using shell powder as additives. Let me start with the agenda. For this presentation, which is we have introduction, methodology, finding, discussion, and conclusion. For the introduction, the aim and objective of this experiment is to conduct particle density and Casagrande tests with different ratio of additive added into soil by determining the specific gravity, liquid limit, and plastic limit. Background of study. The sample was collected in the place near Mersing, Johor, which the shell was air-dried before testing, and were crushed using various ways until it became the shell powder. Methodology. There are two experiments were carried out, which are Casagrande and particle density. The apparatus that I used to conduct the experiment for Casagrande are Casagrande liquid limit device, roving tool, spatula, and palette knives. Can, distilled water, weighing balance, glass plate, drying oven. Next, for particle density, I use density bottle, stopper, distilled water, vacuum sets, timer. This is the procedure that we conducted, which is particle density in lab using our additive 5% of shell powder used for soil stabilization. First, the density bottle and stopper were cleaned and dried before it was weighed and recorded the mass of density bottles. 20 grams with an additive of 5% shell powder are added into the density bottle and it is weighed again. Record the mass and the density is soaked half of the density bottle with distilled water and leave it for 10 minutes. Next, the density bottle was fully filled with distilled water and was placed into the vacuum set for 10 minutes. The density bottle was emptied and cleaned properly for the density bottle to be fully filled again with the stopper. We can see the density bottle is soaked with watching this video. The density bottle is soaked in half with distilled water, including the soil sample. And finally, step 2 until 4 is repeated to find another sample to obtain average specific gravity. Liquid limit. Proceeding to the next laboratory experiment, which is Casa Grande, to find liquid and plastic limit. Firstly, for Casa Grande, we prepared the sample as it requires soil weighing 200 gram with additional 10 gram of shell powder that passes 425 microsieve into the container. Next, the sample is transferred onto a glass plate to mix with water. With palette knives, we mix the sample until it becomes thick homogeneous paste. Then we set up the Casagrande apparatus to perform the Atterberg limit test. I then place a portion of sample into the Casagrande cup and ensured the cup was filled and level. Using the tip of grooving tool, create a canal at the center of the cup and start applying the blow while recording the number of bumps required. We and my friend conducted 3 tests with different states of soils from drier to wetter. After finishing all three different states of soil, we then put it into the oven. After leaving about 24 hours, the sample is weighed and the weight of before and after oven is recorded. Finally, take a small portion of sample to conduct plastic limit and next for oven dry. In this slide are the sample of video of activities we did in lab, which are placing sample in Casa Grande cup, leveling sample, and applying blow.
Minta dulu bodoh. Kita tarik semua. Ada budak telah naik, ada telah naik. Minta dulu bodoh. Kita tarik semua.
We then determine the plastic limit, as it is required to find the type of our soil using shell powder as additive. First, take a small portion of the sample and allow the sample to dry until it enough to shape into a ball. Second, mold the ball of soil between the fingers and roll it between the palms of the hand until the heat of the hands has dried. Next, rolling and treading the soil sufficient until slight cracks appear on its surface. Take the soil sample, the can container for oven dry. Finally, record the mass of before and after oven dry. Findings. Findings for these are the results that I obtained during the experiment for Casa Grande. For liquid limit, I take 3 samples with different of state of soil. In order to get the required number of blow, it is performed with adding distilled water and it is repeated until we get the suitable number of blow. Mass of can plus dry soil, mass of can plus wet soil is recorded during the experiment. Dry soil are calculated by subtracting mass of can plus dry soil and mass of can. In order to get moisture loss, mass of can plus wet soil, it is minus with mass of can plus dry soil. And then we get to calculate moisture content by dividing mass of water, mass of dry soil times 100. The moisture content for each number of blow is 20%, 14.3%, and 18.18%. It is the same to find moisture content for plastic limit by referring to the liquid limit. For particle density, we measure the mass density bottle plus stopper, mass density bottle plus stopper plus dry soil, mass of density bottle plus stopper plus soil plus water, mass of density bottle plus stopper plus full of water. The data was recorded during the experiment. Specific gravity is determined by using the formula M2 minus M1 over bracket M4 minus M1 minus bracket M3 minus M2 from the data given. Finally, we can find the average specific gravity, which is 1.90. Discussion. For the next slide is discussion. In the discussion of the experiment, using shell powder as additive is different without using the additive. Stabilization is a means of enhancing soil strength, density to soils to affect the stability of soils under different conditions. Casagrande and particle density test was conducted on soil stabilization with an additive using 5% of shell to obtain specific gravity, liquid and plastic limit. Consistency and Atterberg limit directly relate to soil stability. Therefore, addition of shell powder alters soil stability by changing the bonding interaction between soil particles. Using shell powder concluded that by filling up voids between soil particles, decrease the permeability coefficient of soil and increase soil stability. Conclusion. In conclusion, through this experiment, it has been shown that shell powder can be used as an effective stabilizer with encountering waste disposal problem as well, along with the economical solution for stabilizing weak soil. This admixture, known for its low cost, significantly less danger out for the environment. Therefore, it can enhance engineering properties of soil. Cost contribution. These are the advantages of cost contribution throughout the experiment I conduct, which is soil stabilization. First, dust control for a good working environment. Second, get to promote the use of waste material in constructions. And the third, substituting poor grade soil. And finally, refine and improve the engineering properties of soil. Thank you.